All right, good morning. Today's lesson is on driving and risk, student activity sheet 6. The bell ringer is review on the last assignment on probability in games. A new video game has the main objective of the game is finding your way through a labyrinth without alarming a huge minotaur. There's a 20% likelihood that you will encounter the minotaur at an intersection in the labyrinth. If you encounter the minotaur, it is 40% likely you will be captured. What is the probability that you will escape the labyrinth if you must turn correctly in 5 intersections? And then what is the probability that you will encounter the minotaur and be captured on the 5th intersection? So let's look at that. Personally, it's going to be difficult to determine it. But the probability that you'll escape the labyrinth if you must turn in 5 intersections, first of all, likelihood to not encounter the minotaur is 80% of the time. But it's 5 times, so it's 0.8 to the 5th power. So 0.8 times 0.8 times 0.8 times 0.8 times 0.8 is 0.32768. There's a 32.8% likelihood of escape. How about if you encounter the minotaur and be captured on the 5th intersection? So we're going to have 0.8 to the 4th power, and then we're going to multiply the last one times 0.2 because guess what? We encounter the minotaur. But we also have to multiply times 0.4 because there's a 40% likelihood you'll be captured. So encountering and then being captured, we have to multiply by both of those probabilities. So it's a 3.3% likelihood of capture if you encounter the minotaur in the 5th intersection. So good things. All right, good things. Hopefully, taking the day off today because my wife is ill. I'm going to go make sure that she's okay, get things done, and be back tomorrow to teach the lesson on SAS 7. So anyway, please share your good things with me via email or however. Let me know in person. I'll try to add them, try to write them down and add them to my videos for future reference. In the meantime, let's go on. All right, so driving your risk. Javier will be at high school senior next year, and he wants to get a vehicle to celebrate his graduation. And his mother researched vehicle safety and found that 1 of every 6 teenage drivers was involved in some kind of accident. Now, while talking to his math teacher, Javier mentioned that he did not think the risk was high enough to be concerned. So he decided to survey 500 students, 230 of whom were male, to help him convince his mother to allow him to get a vehicle. No student has both a car and a motorcycle, and these are the results of the study and the data that Javier had actually collected. So we have 4 rows, males with vehicles and males involved in accidents, females with vehicles and females involved in accidents. Now remember, he surveyed 500. I'm pretty sure that these totals do not add up to 500, and we'll look into that here in a minute. So let's draw a Venn diagram and a chi diagram of each of the data. So Venn diagram, we have a situation where 57 are males and they did not have an accident. Okay, notice that 57 are males and do not have a vehicle. You notice that they figured that out by doing a little process of elimination. We can easily figure out 500 minus males with a vehicle. 150 and 23 is 173, and we'll subtract that from the number of males, which we said in the last thing, 230. So 230 minus 173 will get us the answer of 57. We'll continue on. We know a few things about it. We know that males have vehicles. That's a coincidence here. Okay. 127. Making sure this adds up. I know it's correct. I pulled it right out of the book. Oh, I get it. 127 here are male and have a vehicle. Those that have a vehicle that are not male, obviously are female. For ease of this particular assignment, you cannot be both male and female. Males with a vehicle that got in an accident, 46. This should coincide with the number of males involved in an accident. 40 had an accident with a car, and 6 had an accident with a motorcycle. That's 46, 40 plus 6. Females involved in an accident is 15 plus 4. That should be the intersection of vehicles and accidents that are not male, and that's 19. 15 plus 4 is 9. So we know that adds up correctly. If we had all the numbers up in this, we subtract the sum of all these numbers, or the sum of the vehicles, 173 males and 235 with females. That sum from 500 should give us 35, and that's how we get that information. Now, in a tree diagram, it's a little bit different. We look at the number of males with vehicles and the number of females with vehicles, or number of males and females in the survey. 46% are male and 54% are female. We're going to go through this information. 65% have a car, 25% have no vehicle, and 10% have a motorcycle. And then those with a car, 27% have an accident, 73% do not. Male in a car accidents, he says, is 8%. With a motorcycle, male in a motorcycle accident is 1%. And he wants to use this information to persuade his mother. So let's look at this. Using the data, what is the probability that Javier will be involved in an accident if he gets a motorcycle? And explain your reasoning. Of the 23 males who had a motorcycle, 6 were involved in an accident. Therefore, the probability is 26%. Now, we're looking at 6 out of 23. We're not talking about females here, and we're not talking about the total group. We're just talking about males. 6 of the 23 males who had a motorcycle were involved in an accident. That's 26% of the males. All right, based on these data survey, Javier told his mother that he only has a 1% chance of getting in an accident. Is he correct? Why or why not? All right, Javier is not correct, but he's using only the probability if he gets in an accident, but he's not considering a car. Total probability of getting in an accident based on Javier's survey data is 8% plus 1%, which equals 9%. So it's not a 1%. The 1% is only specific to males. Taking a different approach, he could be considerably off in his comment to his mother. It could be argued that 46 of the 230 males surveyed were involved in an accident, or 20%. That's a more likely argument his mother will use against him. Use your Venn diagram to write 3 facts to help Javier convince his mother to let him get a vehicle. Here's a few. Only 46 males were involved in an accident out of 500. Of the 500 people surveyed, 435 people did not get into an accident. And 127 males with vehicles did not have an accident. What is the probability model you advise Javier to use when he tries to convince his mother to let him purchase a vehicle? Advantages and disadvantages of a Venn diagram. Advantages: if you have fewer factors to consider in your data, a Venn diagram works nicely. It gets a little convoluted the more factors or events that are involved. Disadvantage: it still needs a large amount of interpretation. It's really difficult to look at a Venn diagram and determine probability easily. Tree diagram, here are some advantages and disadvantages. An advantage: a tree diagram enables you to see a listing of all the outcomes. All of them. If you look down this column, it shows you all the outcomes. Accident, with a car, and male. No accident, car, male, and so on. To determine probabilities, you must multiply. A tree diagram enables you to isolate events more easily. We can look deliberately down the line and isolate it to the least possibility of one specific or several events occurring at the same time. Determine probabilities, you must multiply each branch of the tree diagram, and your results are not immediately known. You have to actually do the math. All right, launch. What do you tell your parents when you want to buy a car? Here's a non-truth. I promise I won't crash. You can't promise you won't crash. You don't know if someone's going to hit you. Here's a mega truth. I promise I won't purposely crash into the glass doors at Primeaux Cinema. This picture right here is actually what happened last year when a student decided, oh, I'm going to drive my car. And he hit the gas instead of the brakes, and he ran his brand new Mustang right through the IMAX screen at the Primeaux Theater. Anyway, there's an assignment in the Google Classroom. please get that done as soon as possible. In the meantime, be blessed, be a blessing.